So I've been teaching my friend how to code, and I've been running across an interesting multi-set of problems. In the past, we had books that pretty much taught us standard C++ Windows, C++ DirectX, C++ OpenGL, C++ Linux, whatever. You had a relatively almost unchanging standard instead of changing systems like we have Android and iPhone and all these new phones coming out. We used to just have one or two major platforms, and essentially any type of game you wanted to write, you just picked up a book on whatever you wanted to do, MMO, RTS, it doesn't matter. Now we have a whole bunch of poorly written books by guys that look like they either didn't learn how to put their code together, or didn't learn how to do technical writing, or they didn't edit their code. A really awesome guy likes to do tutorials, but when he puts a book together, he says, "We won't have to do this," and the very next thing he says is, "By the way, you should work with this code that I told you not to put in your base." So I'm tired of trying to teach him and give him books for a solid learning structure when they don't exist anymore. You either get just C or you get just iOS, but you don't get, how to glue your stuff. So this video is hopefully the first in a series of videos that teaches you supposedly after you learned your language. So Objective-C it will be what I'll be using, but honestly you should learn C++ first. It should be standard because it has objects, it follows certain conventions. It could even be Java. Java and C++ are almost identical in syntax. They don't work the same though. C# is almost identical to Java though, so just a C basis. I don't care if it's Objective-C, C++, or Java. C# has a few more features from when I studied it regarding bit arrays, and you'll learn those later. So, aside from the introduction, let's get started to actually try to conceptualize what code is, because you might be thinking like, what can I do? What can't I do? How should I structure it? So let's work with what you have. You have inputs, you have time, and then you basically manipulate data. I'm not going to count outputs because they come in the same lines that they get input. So we have camera and screen, we have keyboard, and well, there's no really output keyboard, but the concepts are the same. It just depends which direction the signal is going. So, scanner and printer. Alright, that's not completely literal, but so inputs and time. These are your two givens. So with any system, usually the hardware level is abstracted for you, and I mean, you say put a pixel on 510, and that's 5 over and 10 down, and then the underlying system knows what pixel to light up. So you don't have to code that part. It's always a given. So you can stop thinking about, oh, how do I put a picture on the screen? Even putting pictures on the screen is usually abstracted for you. The things that you learned in code were integers, floats, doubles. This is data. You learned how to loop, so how to move around the data. You learned how to add, subtract, and bit shift, which is move the data. So you have those inputs. You can't get around the clock cycles, though they're so fast it's hard to tell sometimes. And the clock cycles are basically when these instructions execute. So you have the data which comes in. It could be through a camera or a keyboard, doesn't matter. You can shift it around, you can put it back out, and you can decide when and how much to do at any time. That both involves concurrent programming, which is threading, threads, and looping. And you can access the system time using, that's usually system specific, so there's no code that works universally on all of them, even though they're visuals. The words used are very similar. So those are the basic concepts and the reason. So I'll end this video before it gets longer. All right, final number 2.